Okay, there's one more problem on variation of parameters. Let's see how to solve it. Anyways, for any problem, YC is what is important. So for YC, I'll be rewriting this equation as double derivative is taken as d squared. And then say a normal first derivative is taken as d. And then y is taken common in all. So it's 1 and e power x log x. Okay. So for YP, for YC, what should I do? First, I should write the auxiliary equation, which is m square minus 2m plus 1 is equal to 0. The roots are m is equal to 1 comma 1. So the solution would be YC would be something like C1 plus C2x e power x would be the solution. Okay, do remember, don't get confused with Cauchy-Euler and variation of parameters. Both are important, but then each has its own way to do. Okay, now coming to a variation of parameters where I need to find YP, I have Wronskian which is involved, which talks about linear dependence and independence of solutions. So YP is obtained by giving some particular values to the arbitrary constants in YC. So C1 and C2 are replaced by A and B, and the values of A and B are given as follows. I mean, the formulae for A and B are given as A is equal to minus integral B into Q of X. Q of X is the right hand side of the differential equation. Wronskian of U comma V dx. B is nothing but integral U into Q of X by Wronskian dx. Okay, what is U? Let me write here. U is nothing but e power x. V is nothing but x e power x. Let's find Wronskian of U comma V first. This would be what? E power x e power x. E power x derivative is e power x only. X e power x derivative was 1. X is as it is, e power x derivative is e power x. Okay, so what will happen? What would be the Wronskian value? E power 2x plus x e power 2x minus x e power 2x. Both of them get cancelled off. So the Wronskian value would be e power 2x. Now let's proceed to find the values of A and B. A is nothing but minus of V. V is nothing. V is what? X e power x into Q of x is given to me as e power x log x by e power 2x. This and this gets cancelled off dx. B is nothing but integral e power x into e power x log x by e power 2x dx. Okay, I need to remember integral log x formula just to find the solution for it. Now for this one, what I will do is I'll be using x log x dx. I'll be using UV rule where this would be my U and this would be my V using I late. Okay, so what I'll be having is x integration log x into x integration would be x squared by 2. There's a minus sign outside. Okay, minus what I'll have will be derivative of log x would be 1 by x into x squared by 2 dx is what I will have. Okay, so finally what I'll be having, this x and this x gets cancelled off. Integration of x is very easy. X square by 2 log x. Integration of x would be nothing but x square by 2. Already there's a 2, so will be 4. Okay, now coming to this part, this and this gets cancelled off. Integration of log x, you need to remember, that would be what? X log x. Of course, I can write log x also in a different version. Okay, and go. Otherwise, if you remember, it is x log x minus x. That's the. So I'm done with my YP. So how would I write my YP is e power x is there with a negative sign. X square by 2 log x minus x square by 4. Okay, this is my U, guys. U into A into U. Okay, plus b into b is what? X log x minus x. Okay, this is my b. X e power x is my v. This is how I will write yp. Also, I will write y is equal to yc plus yp at the end, which would give me the solution to this problem. Okay, by variation of parameter. This is how I will solve. Not a big deal. You should be a bit cautious. Thank you.